Hello everyone, it's August 19th. Done with internship. Alright, let's take a look at today's thing. We have a hard problem. Let's see if we can solve this. Oh, I've done this before. Minimum number of refueling stops. Do I remember this? A car travels from a starting position to a destination which is target miles east of the starting position. There are gas stations along the way. The gas stations are represented as an array stations where stations I is positions and fuel. Indicate that the ith gas station is positioned I miles east of the starting and has fuel I liters of gas. Car starts with an infinite tank of gas, which initially has start fuel, liters of fuel in it. It uses 1 liter of gas per mile. When the car reaches a gas station, it may stop and refuel, transferring all the gas from the station to the car. Return the minimum number of refueling stops the car must make in order to reach its destination. If it cannot reach, return -1. Now that if a car reaches a gas station with 0 fuel left, the car can still refuel there. If the car reaches a destination with 0 fuel left, it is still considered to have arrived. So we can do just arrive there, right? Which is fine. So if we have target is what? Is the distance need to go. And the start fuel is 1. We have no stations. We can reach the target. If the target is 100, and we start with 1, we can only go 1 mile. And then the first refueling is at 10 miles, so we cannot do. If it is start with 10, and then we can go 10 miles, which will exhaust if we get 60. Then we can say we can go 60 miles to go here and then do this. So that's 2 stops. Oh, from position 10 to position 60. So we still have 10 left. We then drive the remaining 40 because we have 40 more to filling. Okay. That's a straightforward problem. Yeah, kind of remember this. So we have a starting position, we have end position, and along the way, this is like screaming dynamic programming to me. I just need to figure out what are the states. And we have 500 in length, so O(n) squared. So we're looking at 2, right? It's actually 500. That's not 2. We can't even do O(n) tripled. Oh, we probably cannot do tripled. Squared. Yeah, I do O(n) squared. So what do we have? So what at each stop, what we have is the distance traveled, right? We can say distance traveled and distance traveled and the amount of gas remaining. How about that? Distance traveled and the amount of gas remaining at each stop. At each stop. So let's say at each stop we want to find the minimum number of stops that's needed to reach the destination. Okay? And let's say if we know the minimum number of stops to reach the one in front of it, right? And then for all different refueling situation, and then we can compute if it can reach the end, right? So what does that mean? That means if we have a function, right, which has the distance traveled. Oh, we don't need the distance traveled, right? Because the distance traveled, you're gonna stop to refuel. So we already know the distance traveled. So we all we need to know is So it's not distance traveled. Oh, what is it? The number of stops we used. The number of stops and the gas tank. Is that right? Oh, the gas tank. That's a different problem. That's not 500. Gas tank is 10 to the 9th. Huh. Let's say we have 0 station. A 0 station is just if the start fuel is larger or equal to the target. Right? And if I have 2 stations, yeah, let's simplify it. Starting, we'll have 1 station. And then we have the end. Then we try to see if we can reach the first one. Right? And then from the first one, see if we can go towards the end. Take a 1 stop. And to reach here, you can say, you can go backwards, right? So what's the minimum number of steps to go from here to here? That's the minimum number of steps to go from this to this, right? And a solid example for this. $60, $30, $30 and $40. Start. That's the end, right? So we say, if I go from the start, we can reach anyway, start field is 10. And then if we go, we can hit however many we want to hit along the way, right? When I hit this, we can say, okay, if I refuel here, then I go. Right? Then I hit a thing, then we have the amount of fuel left. So if I have the same amount of fuel when I hit a specific position, then that problem can be recomputed. So it's the index and the fuel left, right? The index and the fuel left. So if I start with certain things, and I start going. And eventually, when I reach the end, but how do I know how many we're going for? How many stops? We can return the value, right? So like if at this stop we have this amount of fuel, what is the minimum number of steps to reach the target? So the question is to return, if we say a DFS, or it's actually, let's call it a DP, helper, DP. So we need a DP. Index, it's not the station, it's a start. The index is -1 because that's the start. And then, right, so we want to find this, and then with the amount of fuel left, which is 10. So we want to find this, and to find this we need to go through the this is +1 all the way to the end, and we try to see if I refuel. Well, we can add another 1, right? Because the stations, one of 500. One of 500 stations, so we can add a 1 to the stations, which is perfectly fine. And we give 0 fuel, right? We give 0 fuel. And we just say from this position, I can get the fuel. Doesn't matter, we can get the fuel. So the total fuel we can get, because we will get the total number of fuel. Now we have a certain amount of fuel, and then we start to go. And we say, okay, I'm going to go here. So we're going to find out the minimum from this going to the end. All right, the minimum from this going to the end. All right. And if at a certain point we try to go to the next one, and we can't, then we shall return -1. You know what? I actually don't return -1 because I want to find the minimum. If we return -1, that's going to take hold. So I'm just going to return, let's say, math.infinite, which is actually more accurate. And yeah, let's try this. My work. Oh, I think I did something wrong. 19 was from yesterday. Shoot. I don't go back here. All right. Yeah, I don't know why it's in there. It should be 20. Because this challenge is for 20. Okay. Actually, I might need math. And not only that, I need area cache. Okay, so here's my idea. We're gonna say DP index and remaining fuel. Okay, and this one I'm gonna return an integer. We say if index is equal to len stations, right? What should I say? I should say if index is and remaining fuel is larger or equal to 0, then we'll return 0. So we have reached the end. Otherwise, we say if remaining fuel is smaller than 0, then we'll return math.infinite, right? Otherwise, we have not reached the end, and we still have fuel. Then we shall try to see for j in range, actually say for I in range, from index. So index is where we are at. So we're gonna do is I plus 1, 2 land stations, right? Just trying to go through each station. And for each one, we can have a result equals math.inf. This is the maximum number of steps. So what do? We say for the next station, so we can do dpi. So remaining fuel, right? We are going to how do we do? So we have remaining fuel. So we're gonna refill it. Oh, hold on. Oh. So we are at this position and we have this amount of fuel. And then we go to this one. So I need to compute, right? I need to actually, this one shouldn't even happen, right? This one shouldn't even happen because I'm not even going to go there, right? So at station I, which is I just say index plus 1, my bad, it's index plus 1. So at station I, we have its position, right? We have its position. So we say its position and the fuel. So we're gonna go there, right? We're gonna go there. Do we refill already at the station when we get there? If we say index, so the index is we are at this location, right? And we say we haven't refilled yet. So we're gonna refill. Okay, so index we're gonna refill first, and then I'm gonna refill, and then I say I'm gonna expand it that much. Okay, let's try that. So we're gonna refill, and then go there. So oh yeah, we don't refill yet. So the remaining fuel, right? So we're gonna refill first. Remaining fuel plus equal to, because I'm stopping here, right? I'm stopping here, which is the start. No, this is stations index 1, right? We will refill. So after refill, we can decide where we want to go. So and then we have the current position, right? The current position. So we say current position is stations index 0. Now we say the next position is going to be stations I 0. Then how much we need to go? I see why you do that. Then you don't have to make comparison here. Okay, so if this one smaller than 0, then we just return math.inf. Yeah, let's do that. That's fine. So we have next position, and then we just say remaining fuel, right, minus next position minus current position, right? And this is the amount of fuel we'll have when we reach the next position. That's the amount of distance between, and then now it costs that many fuels, and then we go here, we minus this, that's the amount of fuel, so we go there, that's the remaining fuel when we get there. So we do this, and we say rest shall equal to the minimum of rest and this. So we go through, right, we go through this many times. After we went through all of them, And in fact, probably can just do next position is this, so we don't have to really write it out. And current position is going to be this, all right? So we don't have to specify it. So yeah, so it's the next position is the current position, and then rest equals to this, remaining field we have, and then we blah, 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 go through everything, and we're gonna return result. So that's our DP. And we're gonna say at value cache max size equals none. So we're gonna just say return DP. So initial index is going to be -1, right? Remaining fuel is the start fuel. I didn't use target. Oh, that's pretty dumb, man. That is not the case. Wait, hold on. What the hell? So when we do this, right? No. We're in this, we need the number of stations to go to the end. Right? Doesn't matter which station you are at. Now, this is not right. This is not right. So we say we can either go this one, or go the next one, or we go the next one. It doesn't really matter. And when we get to that one, right, we need to see if we can go to the end. If we can, then perfect. If we cannot go directly towards the end, then we seek other options, right? We seek other options. And if we have to do a little bit more digging here. So we're in this position, right? And we try to go to the next one. But if we don't have a next one to go, then we arrow out. So yeah, this is not right. This is ridiculous. It's not right. So I know the position, right? Then I just need to see if, let's say, if this is smaller than 0, definitely. Otherwise, we can say target minus stations index. We are in this index. Let's do the refilling first. So we refill, and then we say target minus station index 0. That's the amount of distance I have to go. Then I say you know what? Let's put the target inside, right? Like, why not? I can put the target inside. And let's say stations dot append, right? Target, because the first one is the distance, the second one is the amount of fuel, and the fuel just is 0. It doesn't really matter. And then we can use what we used earlier. We can just say if index is equal to, well, actually index is not equal to. Go to this. Let's say n equals len stations, and we say if it is equal -1 and remaining fuel is largely equal to 1, a 0, then we return 0. Yes, that's the thing. Otherwise, if remaining fuel and this, and then we say we'll refill. Like if this one doesn't, which means we cannot go directly. Like one of these that doesn't work. So I say the minimum steps, and I should return rest plus 1 because I'm taking my current, that's a step I take. Okay, so the remaining fuel, we refill completely, and then we try to go for the next one, right? And then we'll see if we can't reach it, we'll return this, and I'll start from -1 index. It doesn't, this, and we go for here, and then refill. We didn't have a refill, so we should say if index is larger or equal to 0, then we refill. Otherwise, we don't refill. Of course, the start index is -1, so we don't have to refill. And then we try to go for the next one, all of them. We try to go directly for it. But we can actually because I want to skip out earlier. You know what? Yes, so we say the distance is going to be this, right? So this is the distance. And we say if distance is larger than the remaining fuel, then we're going to break. Otherwise, minus distance. Right? Then we guarantee this will never happen. Right? This will never happen. And we have an early break, so we don't have to keep going. And then we get a rest as the minimum number of steps from this to the end, this to the end, this to the end, given the remaining fuel. And we got a minimum, and I need a +1. And how about in this case? So we put 1, 0 to this, so this one has 1 value, right? And the index coming in is going to be -1, which is fine. And then we're going to go to 1, and then position is 1 minus, the starting position. Holy crap, I need a starting position. Starting position should be 0. Maybe it'll be easier. I just say stations equals to, I don't know, starting position, starting fuel, plus stations, plus a target, and 0. All right, and I'm going to start from 0 with the remaining fuel, which is the starting fuel. Yes, and then this one still holds. This is all still holds. And then we don't have to do this. We actually set this one to 0. Alright. And then we'll add, so we have remaining fuel. And then we go to the next one. And then we have the distance. And we say if the distance is larger, then it'll break. Okay, in this case, we'll have a 0. The starting fuel is 1. And then we have target is 1 and 0, right? And then we'll go 0, 0 coming in, and remaining fuel will be 1. And then we go to the next one. And the distance is going to be 1 minus 0 is 1. And if distance is larger than the remaining fuel, no, because they're equal. So I say I'll go dpi, which is this one. Remaining fuel minus distance is 0. So we go here, right? index is n minus 1, which is true. And then we feel, okay, now we return 0. So this one will return 0, right? And then this one will plus 1 because I count the first, right? I count the first. So if I count the first, which I shouldn't count, so at the end, maybe we should minus 1. Because we always have to start in the first, so we cannot skip the first one. Okay, let's try. So 1, this, give us 0. And 100, 1, 10 and 100. Give us minus 1. Ooh. Res equals dp 0, 0. Let's say return res if, and actually let's say if, nope, res minus 1 if res is smaller than math.inf else minus 1, like that. Okay, the last one. Answer is 2. Target, start fuel, stations. Okay. Run. Oh, kind of slow initially. All right, let's try this. 找你。Oh, time limit. Oh, it is correct. How we got time limit with such an easy test case? Because there's so many refilling options. Huh. Look at this. 116. Oh, we didn't even cover half. Man, that was whack. That was so whack. So this one, TLE. Ay. I already break early and it's still not enough, huh? Like, how is this one? How is this one TLE? I don't understand. Or like something in the past was too much, causing this one to TLE. Oh yeah, seriously. This one's TLE. Huh. That's awesome. Very awesome. I don't even know what this one is. No, I'll do it. Yeah, this is slow. What the heck? Super duper slow. Even my cache is not working. Let's see if we can peek into this. Just, ooh, almost got stuck. Because this one changed, the field, the remaining field, there are too many options. Wait, hold up. Remaining fuel. Oh, you filled up. Oh, shoot, you filled up. Oh, yeah, you can carry you on. I see. Yeah, it's not working. When you fill up, you have so many options, right? That's one, basically, you have all the options to go. And then it goes all the way down, and then we start to struggle. Like, what if we try to go as far as we can? Right? So we refuel, and after we refuel, we will try to go as far as we can. And then we refill there and try to go as far as we can. So it's kind of like greedy, right? If we go here, and then we immediately go out. So if we are thinking about that way, so in here, because the reasoning is, yeah, let's say I don't go as far as I can, and I go a little bit shorter, and I claim that this path leads to shorter, which means if I go as far as I can, I mean, true, if you go as far as you can, and if you fail, right, then you scale back. Okay, so we go as far as we can, and if we fail, then we scale back. And we can still do cache, which is fine. We just go all the way. We can do binary search, right? Which is perfectly fine. We do binary search, on that, and we do binary search on that, and then we go to the furthest we can, right? And then that's the index. And from this, we try to find the DP again. And if it returns, let's say, a value, if it returns infinite, then we dial back. Try to go this one. Try to go this one. Right? But if it succeeds, like if every step we go the furthest and then we succeed, then we say that is the way to go. Okay, try that. But before trying that, let's take a break. We also need to get some food tomorrow. Oh. If they have tasteful. Bad boy. Very bad.
Oh, you want tasteful?
I don't get anything.
The fancy stuff?
Oh, I like to get tasteful. They behave much better on cake.
Even though it's not blue tongue?
You know, it's not blue tongue. It's better than fancy fest.
Really?
Yeah. Yeah.
Somebody more than you.
Somebody's more than him. Oops, more than him too. John was a total poopy machine.
I have to do that again. So. I try to massage her ears.
If she doesn't squeeze her way out.
Oh, we can't see the fluid though. I don't know.
Which cat will allow you to do that? It's not for you. I think it's a positive sign. It was good. Lots of tea, lots of poop. Actually, not lots of tea, but lots of yeah. I was stuck right now. Jimbo. There's nothing.
That's the first one.
Yeah. No poop. It's understandable. Our boy eats so little. He's not an eater.
Are you eating?
Good.
I say you're not an eater.
phone and go inside, she might just start out. Yeah, you need to go to the bathroom before going to bed. No, you know, it's easy. She smells way better than before.
Gross, right?
What was that? Not too bad. Not too bad. I think what else? I'll regroup a little bit. It's definitely possible. Go to reach most fuel. So we have this amount of fuel. We have this range. We go to one time highest. Go to the log to have the highest remaining fuel. Highest remaining fuel. So we can do, put all these into it's time to heat. Right, so here. Highest remaining fuel. For each step, I want to find highest remaining fuel. And if from the highest remaining fuel we cannot this. We got this. Alright, back. Man, this is tough. I kind of feel like, can we do this with Dijkstra? I don't know. I mean, these are just different nodes, alright? So we try to see, and each node has like the distance associated with it, which means when you get there, like if I say I am however many distance away, and I'll refuel you this. So if you reach me, that means yeah, it's a position. I was thinking about like we go to the place that give us the most remaining fuel. But that doesn't feel right. Give us the most remaining fuel. That doesn't feel right. Because you could go like 1 mile and then give you the most remaining fuel. Okay, why? Maybe we should figure out why this one failed. Just we go to the same one but with different values. Do we have a hint on this? How do we have a hint? It didn't give us hint. Probably dynamic program. Greedy. Yeah. Priority queue. Maybe it is. You know? Yeah, I see it. We have 60, right? Then we can go to this one. Use 40. But use 20. Use 10. My bad. Use 10. So, hold on. So we definitely need to go to 1060, which we have 60 gallon, right? And then the distance, so the next one becomes the net increase in gas is 30 minus 10 is 20, that's plus 20. And this is plus 10 because I have 20 distance, and the last one is 60 minus 10 is 50. So it'll be minus 50 plus or minus 10. So I say we go to the one with the most. So we go to 2030. Okay? So we go to 2030, we give us 80. And we have 80 left. Right, we can go to here, which is 70. It's actually a better deal because 70, we only have 70 left. Oh, that's net gain. We can actually, oh, this is the net. Or maybe we should go for the longest potential drive. What do you mean by that? What I mean is, each one, when we reach, we know, right? We have 80 miles. We have 80 miles to go. So from here, we can go 80. And then we can reach, how far we can reach one. And I'm at position 20, so I can reach 100. If I go here, I have 70. Plus 30, I can reach 100. If I here, I have 50. Right? I have 50. And I am at 60. So I can go to 110. I go to 110. So I go to the ones that allow me to go the furthest. Okay? So you're saying every step we go to the one that allow me to go to the furthest. That allow me to go to the furthest. So what, we just go through every one and see which one allow me to go to the furthest. So we go there, and then from there we see her. Okay, so this is like solution 0. Okay, it works. Yeah, but I'm not sure I want to play that game today though. Okay, let's see, solution 1. What are we saying? What we're saying is we want to find one to allow me to go the furthest. And this is pure greedy, right? That's pure greedy. So index, right? So we're gonna say, so let's say we go to this one. So now we're here, and we know the remaining fuel, right? So we say the remaining fuel is equal to start fuel, right? And then your index let's add a station. Say stations.append target 0. Okay. So we have remaining fuel, and then the current index, right? Current index, and we say, and a current, if we can go, so res equal to 0, right? While what? think we'll always end up at the last one. Because the furthest, now we'll go here, and then when we have these choices, we'll go the furthest, whatever, we'll go to the last one. If we cannot make it, because every step we try to go to the furthest, right? Which means if we go other things, we'll actually go slower. So we shall say, let's go while true, right? Then now we should not do this. Alright, we say if the index starts with -1, okay? My index starts with, no, index starts with 0. And now we say if index is equal to length stations -1. So we are at the last station, right? We are at the last station, but we can't reach we're at the last station, but we cannot reach. How do I say that? We say we have the remaining fuel, right? Anyway, so the remaining fuel plus equal to stations index 1, right? That's the current fuel. And then say if this and target minus stations index 0, if this thing is larger than remaining fuel, then we just return -1. We say, okay, that's impossible. Otherwise, we say if target minus stations index 0 is smaller or equal to remaining fuel, then there's a return res. Okay. Otherwise, we'll try. Okay. Otherwise, we try. So we have the current index. Right, now we just go index plus 1. Right, index plus 1. Okay, so we say index plus 1, and we try to see for I in range, say index plus 1 to land stations. Then we want to find out the max reach index. Right? How do we find out the max reach? So we have the current. So what we do is we have the remaining fuel. So we do the remaining fuel, right? And minus stations I1 minus stations index actually 0 is the distance. So the distance to reach the next one. So I minus this, right? Then plus stations. Because from this point, right? From this point, the amount of fuel I have plus I and 1. So this is the amount of fuel I have when I reach that thing. But that doesn't specify the max reach. The max reach shall be this. This is the amount of fuel I have. Then it's also plus I 0. So this is the max reach, right? So say reach equals this. Say if reach is larger than max reach, then say max reach will equal to reach, and max reach this will equal to I. And then blah blah blah, we'll go through all of these. Then I have the max reach. Then I just say index is going to be max reach I, right? And then we will yeah, so index is the next one, and we need to readjust the fuel. So we need to readjust the fuel, which basically we say remaining fuel, right, minus equal to stations, because we want to go to max reach I 0 minus stations index, current one. So that's the remaining fuel when we reached there, and the index equals, so we gotta go back up, right? I don't know, does this one work? Station 1. Index out of range. Well, of course index out of range. Okay, let's add it to it. Let's say stations equals 0 and start fuel plus stations. And this will be 0 to start with. And doesn't seem right for the others. I didn't even change the result. Rest plus equal 1. How about this one? So put 0, 0 in it, right? So I start with 0. Refill. Okay, so refill to only 1. No. Yeah, I thought I just refill to 1. Index equals to the last one. No, it's not. It's the beginning. And then we'll try to see if we can reach and the reach probably is negative. We have to reach it first, right? So we say if remaining fuel is larger or equal to this, then we do all this. If it's smaller, then we just break, right? or we can just say if remaining field is smaller than this, then we just break. Then we cannot even reach. If we cannot reach I, there's no possibility we can reach the next one. And then we can say, okay, if we cannot even reach the next one, right? We say if max reach this is still smaller than 0, right? It's still smaller than 0, then we should return -1. So we can't even reach. Otherwise, we can try. Okay, can we do this? I'm not sure, so we're gonna have to put this in here. Try it. Name solution. Okay. iPad. Oh, it worked for this one. So this is 6. Maybe this is the solution. You wanna try? All right, let's redo a few things. Oh, I can do this. Okay. Try it. No, wrong answer. Oh, it should be 4. This one probably can debug it. What happened? Five. Max reach, we can 5. So that's a 1, 2, 3, 4, 5. Yes, because I use it up. Right, then I can get 141. So I go to 5. And then I try to see 141. This is 299. Doesn't reach, so okay, 141. We'll try to see if we can go. Can we go to 444? Oh, shoot. Oh, you can't. You cannot go to max reach. What do you do? You fall back? Maybe, yeah. Maybe that's why there is a... So you try all of them. So you go to max reach, right? And you go, and you fail. Then you scale back. Then you try it again. How is that any faster? You scale back, and you do it again, and you fail, and you scale back, you do it again, you scale back, you do it again. I mean, the thing is, if you succeed once, right? If you the first time you succeed, then you should be successful. Okay, let's try this. So instead of just try it once, let's do, gosh. Okay. We still have the index, remaining fuel, right? And do we return anything? We should. I mean, we're not really. We shall return. Let me think. Shall I have the steps? Okay. No, I don't think we should return anything. And we shall have a self.res. And we're not returning anything. Okay. Okay, so we say remaining fuel, that's fine. And we say if this, actually we can say true or false. Okay, let's just do true or false. Say if this and this, then simply return false. If this, then alright, first of all, if steps, right, we count, so we are here, right? So steps plus 1. So yeah, that is the steps. We just haven't refilled yet. So we go here, then we refill. So if steps is larger or equal to self.res, then we just return false, because we cannot get even better than that. If this, return false. And if go to the target, we can do, then we say self.res equals steps and return true, right? Otherwise, we're gonna build a heap. Let's say a heap is equal to this. I'll just import. Okay. So we're gonna do a heap. And then we say for I in the range, the remaining, right? If this, otherwise is my reach. And we're basically just gonna do heap q dot heap push heap. We're gonna do reach and maximum reach, so it should be minus reach and I, right? So after we get the entire heap up, then we just say while heap, right? Max reach and max reach I equal to heap q dot heap pop. So I'm going to pop the heap, and then, right, and then what? And then we say we're going to go to the max reach, right? And refill then we just say dp max reach this, refill shall be remaining fill minus something. Actually, we don't even need max reach, right? This value itself is irrelevant. We're minus something, minus this, right? As remaining fill. And steps plus 1, the next step. And we say if this is true, no, if it is false, what does true and false mean? Like in my current, I already have this much of steps, right? If I go and it tell me is true, or it tell me it's false, so I still hold belief that the first time we reach, so if it's true, yes, if it's true, which means we have reached, then I will return true as well. So I just don't go. Otherwise, I will try again, try again, try again. Once I try all of them, and then we're gonna return false. And then we're gonna call dp, index is 0, start with 0, steps is 0, right? And we say if dp, if this one gave us true, then we return self.res. Otherwise, we return -1. Okay, this is my new thing. Run it. List has no heap push. Heap queue. Oh, now this one pass. Oh, now they all pass. All right, let's try this. 找你. What the heck? If I like 299, huh? Should be 5. Output 6. Oh. Then what's the point of returning anything? You're saying we should just keep trying. But then we just try everything, right? We're just trying everything. We don't stop early. I mean, the whole purpose is to stop early. I mean, we can stop early here. And we stop here. And update here. Hold on. What if we, let's say, don't stop early? And we just return. If this, we just return. If this, we just return. If this, then we also return. Right? And we just keep going. Right? Keep going through all of them. And we just say return self.res if self.res is smaller than math.inf, else -1. Does this one work? Invalid syntax. Of course it's invalid. Nope. Doesn't work. Oh, because I didn't call dp. It's dp000, right? No, I all pass. Huh. Maybe this is the thing. Oh, shoot. Try this. Yeah, I mean, it's just, I didn't really do any early stoppage, so I don't know. But oh, we hit 120 now. Yeah, this is not going anywhere. This is not going anywhere, man. Alright, I give up. It's been 1 hour and a half. I don't know. DP. How I did DP. How's my DP not working? Oh, it's so simple. What the heck? The farthest station we can get to using I refueling stops. Wait, hold on, this one is also the farthest location we can get to using I refueling stop. That's just the thing with DP. You need to find the right way to describe the problem. The farthest location we can get to using I refueling stops. We want the smallest I for which dpi is largely equal to target. Okay. Okay, let's see if we can figure out just by reading this much. So we want a dpi where the I is the farthest we can go. So if we know dpi minus 1, right? If I know dpi minus 1, hold on, this one, let's also put this one here. Although I have no clue what the, so I just put minus 1. What do we want to know? If we do one stop, what's the furthest we can do for one stop? And if we do I stop, what's the furthest? So if we do I stop, right, then the furthest we can do is the furthest we can do in I minus 1 stop, right? So for I minus 1 stop, so one stop, okay? So we just go through all of them, we go through all of them. 0 stop, we can go this far. And 1 stop, we go through all of them, pick the one that is able to, then we find the maximum. This is the max reach, right? That is the maximum reach. So we put it there. So that's the maximum reach. That's the 1 step, right? We can go that much. And then we say 2 steps. So 2 steps requires the maximum of 1 step. How do you find the maximum of going 2 steps? So we have to go one step and we have to go another step, right? So, and for one step, what I can say, the ith step at let's say the jth step at the jth step at the ith station. What is the furthest we can go? So it could be the first step at the jth, the ith, and that's the furthest we can go, and that's the furthest we can go, and that's the furthest we can go. Now, if we want to find the second one, then we go to the first row, right? Because that's, let's say, the zero step with a zero station. That we have a value, okay? And we 1, 2, 3, all these stations. And then at the first step, what I need to go is go through the zero step, right? One by one. And for each one, I say, can I go to the next station, right? At the zero station, now I try to see the first station. Can I go? If I can go, then I give the maximum. And then, can I go this? I get this, this, this. And this one will give us a maximum value. And then we recorded it, right? Now 2 steps. Then we need to go to 1 step, right? So the 1 step, if we have 0 steps, so 1 step, and then go to 1 step to find, so let's say, this is the furthest we can go at 1 step and a first. That's the furthest we can go. So we go to 2 steps, right? And then we say, okay, I want to see if 2 steps, well, 2 steps will have to be at least in this one, right? If we go 1 step, 2 steps, so at least in this one. So we start from here, and we want to see is the second stop. So we're going to see all the stops before, right? Okay, all the stops before, and then they have the maximum reach. So say the first stop, the maximum reach. Right, we have the maximum reach. Then we say if we can reach here, then we say, okay, if we go the first, like if we want to reach this in two steps, then that's the maximum we can go. Or we can reach this in 2 steps, we can go this and this. This in 2 steps, we go this and this, right? So for each level, go through and I'll stop once it's too far. Yeah, and we have the maximum reach in this. So if it goes beyond the maximum reach, then we just stop. And then we'll go to maximum reach. And whenever we find out the maximum reach is bigger than, then we just end. Okay, let's try this. And actually, this is so tough. Maybe tomorrow I can continue. I kind of don't want to keep doing this. I'm a bit tired. All right, so what do we say? We say we have a DP table. Okay, we have a DP table, which is going to be this. And I want to have n equal to len stations plus 1. And this one is say 0 times n, and dp00 is going to be the starting fuel, right? Okay. So that's, and then we say for when do we end? If we cannot fill a row, that's when we end. I feel it's not right. It's like Owen tripled. Let's try this. So steps equal to 0. So 0 step, right? Just say while true. So for 0 step, for the first step we go to, and for 0 step we go to 0, and then we just say the maximum reach of this step, which is just the maximum of this. So I'm going to say for I in range let's say temp 0 times n. So for I in range, steps minus 1, right, to I plus 1. Actually, just to I. Right? To I. No, it's not I. 2 steps. Right, 2 steps. So for all this, so that's just each one of them. And we say if we say if dp minus 1 what is I? I is each one of the current. No, I is not a current. I think it's have been a j. If a j in range steps to n, that's the j. Like to reach this with this amount, right? And maximum we can go 2 steps this, okay? And then we say for I in range steps minus 1. It's not steps 1, it should be, yes, steps minus 1 to j, because I cannot reach j. So if the max we can reach, right, the max we can reach is larger or equal to where I am, the stations, right? The stations j of the minus 1, 0. So if the maximum we can reach from the previous is larger or equal to where I am, then we can say temp j, right? Temp j equals maximum temp j, and so the amount, so the maximum we can reach from this, it says this much, right? So the maximum we can reach from there, right? From here, maximum we can reach is this much. So if we use this, maximum we can reach minus this, that's the total amount of fuel. Or we can just say maximum reaches here, and I am here. So when you reach me, this is the amount of fuel left. Yeah, maximum we can reach basically is just the distance plus the fuel. And I have my current distance, right? So if this minus this is going to be the remaining fuel. So the max I can reach would be the remaining fuel plus what we can refuel here, right? Then plus. So that shall be the maximum we can reach from there. So maximum we can reach from there minus where I am, right? Minus where I am. That's the additional fuel plus what I can refuel at where I am. And after refuel, I will plus my position, which is just this maximum can reach from there, and plus what we can refuel. So basically just this thing. And then we'll go through this, right? Entire thing. Now once we're done, right? Once we're done with all this, we say if maximum temp is larger or equal to target, then we return steps, right? Otherwise, steps plus equal 1, and we say, actually, no, we just realized dp. So we can just do this. All right, dp0 is this. And we just do dp, and then we do dp, and then we say dp equals temp. Then we go back up, right? And then we try. And if else, hold on. What is the end game? So if it's smaller, which is fine, we just do another row, another row, another row. But eventually, if steps, right, while steps shall be so the maximum steps that you just do every single one, all right? You cannot go more than that. So while this should be smaller than n, right? Because if we reach n, then there's nothing. We have no more left to do. So if we don't return this, and then we just return -1 here. So this is my solution 2. Arrange. The first one. So n is 1, so dp is 0. P0 is target, which is 1. Steps is 0. 0 is smaller than 1. Okay. And we go in. Temp is this is 0. And steps is 0 and is 1, so 0j is 0. Steps is 0. Okay? Steps is 0. So maybe we should say maximum of this and 0. Nope. Fail every single test case. By 1. Huh. Maybe I should just do this, right? Because, yeah, we did take the steps, right? We did take the steps. But we still fail the first case. But how? So j is 0, this is 0, so this doesn't go. So steps is 0, so step plus equal 1, steps become 1. And this does not update. Holy crap. How do we incorporate? Yeah, it shall be able to incorporate steps. We have the 0 steps, all right? And then, if you're 0 step, then you should go to 0, but you cannot go to 0. I mean, I don't. Yeah, how to make sense of this? starting from first row, right? J in range. Steps, the first step. And for I shall be the previous one, but we don't have any previous one, so we don't do anything. That is a special case. Okay. Just go. Zero step is needed. We definitely have to do it. This is the 0 steps, right? You know what? 0 step. Step should be -1. don't know. I pass everything here, but it feels just really hacky to me. The 0 step, right? Right now the 0 step. And we go first step, second step. So 0 step, just do this, right? And the previous step. Doesn't matter, we can just do -1 to 0. So this is the previous reach, which is 0. Larger equal to stations J 0. J is 0, the 0 step, which is 0. Yes, so we can calculate the maximum reach we can get is dpi, which is previous maximum reach, plus that's the start fuel. Alright, and when it's done, we get a maximum. If it's larger than target, then we return. So that's that. So I run this. 32. Okay. Try one more time. Time limit. Lord. All right, give up. And let's see what we have in the past. You know what? Let's try this one first to see if it even works. Yeah, this one times out. Doesn't really time out. But hold on. Oh, this is another TLE. Okay, let's try this one. One 957. Oh, this is faster. Much faster. The heck? It was so easy. What? Okay, this is a DP. We have the start fuel. This is the maximum we can go, yes. And then we go the distance and the fuel, yes. So for each one, for each one we say the maximum what are we saying here? We want to find, right? For this step, what is the maximum reach? So the first step, we're on the first one, right? And for the second step, we're looking at the second. We're looking at the second fueling station, and that's the second step. The second step can go really far. So I'm at this position, right? I'm at this position. And then I go through all the things in the past. So like, this is a 0, right? If the 0 can reach me, then I can update it. If 1 step can reach me, then, hold on, the 0 step, I've already done, right? 0 step is just that. So, but we still go from 0. If 0 can reach me, then which means 1 step can be upgraded. If 1 step can reach me, then 2 steps can be upgraded. If 3 steps, then the 4 steps can be upgraded. And for each one, we just update, update, update. Oh, I think I kind of understand now. So we have dp is equal to start fuel plus 0 times 0 times 0 times land stations, right? And then we say for stations, right? For I position and fuel in enumerate stations. Okay. And then what? We have to go from the beginning of dp, right? So we say for j in range from the beginning until I plus 1, because that's just a step, right? Because 0, not 0, I as a first station, so that's a 1 step. So we go 0 step, right? So for each of them, each of these j, what we're gonna do is we'll try to see, okay, from here, right? So we say the maximum that we can get is dp I, like this is, let's say 1 step, and then I'll update this. Oh, I cannot go left to right, because every time I update, right, so the j, let's say j is 0, and I'm updating j plus 1, because that's 1 step, right, and then I go to that's being updated, so I cannot have to go back to front, which is just gonna go b from I. So every time we say dp j plus 1, right, shall be equal to maximum dp j plus 1, that's the number of steps, right, of what? dpj, that's the previous step, a maximum you can reach, and the maximum you can reach plus, should be just plus my fuel, right? The maximum you can reach, and I have my current position, so should be my position, the maximum you can reach minus my position, right? Should be maximum you can reach minus my position, right? Which should give us the additional fuel, and but there is a thing, it should be like if dpj, the maximum I can reach is larger or equal to my position, then this one. If you cannot reach me, then you just cannot do it. This is the jth step, right? The jth step. So from the jth step, we can reach the ith station. Then j plus 1 equals maximum, j plus 1, and the j step plus the fuel that I can get. That's the maximum we can go. Then we'll do this. When we're done, we just say for I in range all the way to length dp, right? If dpi is larger or equal to target, then return I, because I is steps. Otherwise, we return -1. Okay, let's try this. Just want to pass everything as well. I'll just see if you pass this one. That is the stuff. But it failed. Yep. We'll have to revisit this one tomorrow. Failed. Yeah, I wasn't able to figure out this DP solution. So the thought, the DP is to find the maximum reach at each step. So dpi is the max reach at ith step. Then we just need to find the smallest I such that dpi is larger or equal to target. So to build dp, we go to each station, and we know that at the jth station, right, at the jth station, the max number of steps is j plus 1. Thus, we can query the max reach at j minus 1 0 steps, right? If it can reach if at like k step if at that step it can reach the jth station, then we update dp. Then we update the max reach at dpj plus 1. Sorry, not dpj plus 1, the jth step. Let's call it kth station. The max number of steps is k minus p plus 1. As we can query the max reach at k minus 1 steps. If at j step we can reach the kth station, then we update. And we're up to the max reach at j plus 1 by finding the max reach, using max reach at the kth station using the max reach at jth step, that is dpj. Thus, dpj plus 1 equal to maximum dpj plus 1 and dpj plus stations k and 1. If we cannot reach the kth station at j step, we ignore it. And since we use a 1D dp array, the query must go from right to left. Otherwise, we will update a field or update a cell in dp before even visiting it. Yeah, we'll update a cell in dp before visiting it. Okay, let's put all these up, do another submit, and then call today a day. So tomorrow we will have to come back to this. So there's another solution out there. Let's record this one. Pretty bad. Alright, anyway, I'll see you guys tomorrow. So tomorrow we'll do whatever we need to do and we'll come back to this problem because we have yet another solution to go through. Alright, adios.